Alright guys, so here we're going to be talking about proving trigonometric identities for our exam. And we're going to be looking at number 5 from the review sheet on proving trig identities, which is the following. 1 minus cosine x over sine x plus sine x over 1 minus cosine x equals 2 cosecant x. So here we have a trig identity, and we want to prove that this is truly a trig identity. So the way we do this is we either go and look at the left-hand side of the equation and try to see how we can get algebraic manipulations to get the right-hand side, or vice versa. But we need to have certain identities in our heads already. Particularly, the Pythagorean identity must always be stored ready for usage when we have to prove trig identities. So the one that we need to know is cosine squared theta plus sine squared theta equals 1. And from here we have 4 more that stem from this, right? We have like the couple of cosine squared theta is 1 minus sine squared theta. Sine squared theta is 1 minus cosine squared theta. And we also have the 1 plus tangent squared theta equals secant squared theta, and we have 1 plus cotangent squared theta equals cosecant squared theta. So these are all identities that stem from the Pythagorean identity, which is a very important identity to have in mind for these types of tasks of proving trig identities. So here, this is what we have. And we see that this left-hand side of the equation has a little more things to simplify than the right-hand side. So it would make sense to go from the left-hand side, right? So this is my left-hand side. So we're going to call it LHS. And this is going to be my right-hand side. So I want to show that my left-hand side is equivalent to my right-hand side. And I'm going to do that by using algebraic steps. So here we have 1 minus cosine x. I'm just going to rewrite this again. And I realize, what am I trying to do here? This is my left-hand side, and I'm trying to add 2 fractions together, 2 rational expressions. In order to do so, I have to have the same denominators. So right now I have sine x and 1 minus cosine x. So we multiply by what's missing from the other denominator. So here I need to multiply both sides by, top and bottom, by sine of x, because I'm missing sine x here. And this is missing the 1 minus cosine x, so I do 1 minus cosine x over 1 minus cosine x. And when I do so, I have the denominator 1 minus cosine x multiplied by sine x. And for now, I'm just going to leave it as a product. And here I have 1 minus cosine x multiplied by 1 minus cosine x. Plus, I have sine x times sine x is sine squared x over 1 minus cosine x sine x. Okay, so this is what we have so far. Now I realize I need to use some algebra here and expand this product. So I'm going to FOIL here. And when I FOIL, I get 1 times 1 is 1. And I get minus cosine x plus cosine squared x. And I have here sine squared x over 1 minus cosine x sine x. So now look what I have. Same denominator. I can combine the numerators together, right? So I'm going to write this over here. And then I have this cosine x repeated here twice, the negative. So it's going to be 1 minus 2 cosine x. I have this cosine squared x plus sine squared x all over 1 minus cosine x sine x. But then I realized, wait, I got cosine squared, sine squared. What is that? The Pythagorean identity. So this here, this equals 1. So I can rewrite this now as 1 minus 2 cosine x plus 1 over 1 minus cosine x times sine x. But then I'm like, wait, 1 plus 1 is 2. So I got 2 minus 2 cosine x over 1 minus cosine x sine x. But then I see, wait, I can factor the 2's out from the numerator and I get 2, 1 minus cosine x over 1 minus cosine x sine x. And then I see I have a 1 minus cosine x and a 1 minus cosine x here. So I can cancel these and I get 2 over sine x. But what am I trying to show? I'm trying to show that the left-hand side equals the right-hand side, which is 2 times cosecant x. And it just so happens that 1 over sine is cosecant, so then I have 2 cosecant x, which is the right-hand side. So all of this work here demonstrates that the left-hand side equals the right-hand side. And so then you can say, therefore, the left-hand side equals right-hand side, and we're done. I have shown that this is indeed a true identity, because I can go from the left-hand side and apply algebraic manipulations or steps to get an equivalent expression on the right-hand side. That's how you do number 5 from proving trig identities. Now let's look at other trig identities that we can try to prove, okay? From the review sheet, there's like 2 sections on proving identities, so we're going to go to the second section. Let's look at number 1. Number 1 is sine x plus cosine x squared equals 1 plus sine 2x. So again, it's the same idea. How can I go from the left-hand side into the right-hand side? That's really the question. Or the right-hand side to the left-hand side. Up to you. But here it looks like I'm going to try to see if I can simplify the left-hand side first. Let's look at the left-hand side. I have sine x plus cosine x squared. Can I simplify this? I can. I need to expand. So this becomes sine x plus cosine x times sine x plus cosine x. Because I'm multiplying this expression to itself twice, right? It repeats twice in the product. Now I can do what? I can FOIL. Sine x plus times sine x is sine squared x. Sine x times cosine x is sine x cosine x. This is cosine x plus sine x. Well, cosine x times sine x, sorry. And then finally cosine x times cosine x is cosine squared x. So this is what I have when I expand these 2 binomials, when I multiply them. And then I realize, wait, sine x, sine x, sine x, multiplication is commutative, meaning I can change the order around. So there's 2 of them. So I can write this as 2 sine x, cosine x. And then I realize, wait, there's a sine x here plus a cosine x. And then again, what must we be able to recall? Sine squared plus cosine squared is the Pythagorean identity, which equals 1. So this equals 1. This guy here with this guy here equals 1. You add them up. And now I'm like, wait a minute, what is this guy? Now this is one of the double angle formulas. Remember, this is double angle formulas, which is sine of twice the angle is 2 times sine of the angle times cosine of the angle. So then I realize this is 1 plus sine of twice the angle. But this is exactly what I'm trying to show, right-hand side. So I just showed that the left-hand side, through some algebra, equals the right-hand side. So then, we're done again. Okay? Let's look at the next one, number 2. Number 2 is 2 times tangent of x all over 1 plus tangent squared x equals sine squared. Sine twice the angle. So again, left-hand side, right-hand side. Can we show that the left-hand side equals the right-hand side, or vice versa, the right-hand side equals the left-hand side? Well, you can see the left-hand side here is a little more involved, that an expression that has a little more things going on, so we can try to see if we can simplify it. So let's try that. So left-hand side is 2 tangent x over 1 plus tangent squared x. But then, what do I see immediately? Or should I see immediately? 1 plus tangent squared x is secant squared. So I can rewrite this as 2 times tangent x over secant squared x. And then I'm like, wait, does this help? At the moment, it may seem like it doesn't. But then, remember, what's one of the techniques that we can apply? Rewrite everything in sines and cosines. So then I can rewrite this as twice sine x over cosine x. Over, what's secant? Secant is 1 over cosine. And I have this. So look what I have. I have a product here in the numerator, a fraction, and I have a fraction in the denominator. What happens when you divide by a fraction? You keep change and you flip the denominator, which is a fraction. So we get twice times the fraction sine over cosine. Now we multiply by the reciprocal of 1 over cosine squared, which is cosine squared over 1. And then we realize, wait, the cosine x cancels with the cosine x here, with one of them up there. And what's left is 2 sine x times cosine x. But what's 2 times sine x cosine x? It's exactly the double angle formula for sine. So this equals sine of twice the angle, which is exactly what I'm trying to show, right hand side. So then I show that the left hand side equals the right hand side. I'm done. I've shown that this identity is indeed a true identity. Okay, so that's how you prove trig identities. There's usage of algebra throughout. You have to be able to recognize Pythagorean identities and the identities that stem from it. You have to be able to recognize the double angle formula for sine and also for cosine. And if anything else fails, if you have a complicated scenario such as this, you always want to try to rewrite everything in sines and cosines, and then use algebra to see if things cancel out, which normally they will. Okay, so let's do one more. So we're going to kind of go away from the identities and talk about addition and subtraction formulas. So remember, what would be addition and subtraction formulas? You know that cosine of A plus or minus B is cosine of A, cosine of B, minus plus sine of A, cosine of B, sine of B. And we know that the sine of the sum or difference of angles is sine of A, cosine of B, plus minus cosine of A, sine of B. So let's look at number 5. In the section that says addition and subtraction formulas, values of trig functions. It says find the exact value. So they want us to find exact value. Remember, exact value is it's not the answer that's given by the calculator, which is an approximated decimal expansion. We want an exact value, which usually includes fractions and square roots if need be. So here we have number 5, which is cosine of 3 pi over 7, cosine of 2 pi over 21, plus sine of 3 pi over 7, times sine of 2 pi over 21. So we first need to see, wait a minute, what is this form? I got cosine repeated twice. So it's going to be a cosine. It's going to be a cosine formula. So we're going to be considering this guy here. And then we have a plus here, but the plus here is denoted or related with the minus sign. And this is my A, and this is my B. So then, this is going to be cosine of A minus B by the formula, which is 3 pi over 7 minus 2 pi over 21. Now I need to subtract two fractions again. How do you subtract two fractions inside here? Same denominator, 7 and 21. I need to make this into a 21. So I multiply the 3 pi over 7, multiply by 3 over 3. And so this equals 9 pi over 21 minus 2 pi over 21. Now I have the same denominators, keep the denominator the same. Then I can combine the numerators, so 9 pi minus 2 pi is 7 pi. 7 goes into 21 3 times, so this reduces to cosine of pi over 3. The cosine of pi over 3 is something that we should know. Pi over 3 radians is the same thing as saying 60 degrees. So cosine of 60 degrees or cosine of pi over 3 is going to be 1/2. So this whole expression here equals 1/2. Right? Hopefully that helps with the review on trig identities, proving trig identities, and addition and subtraction formulas. Okay? Best of luck.